Okay, we're looking at 3.1. You can see the only topic here that we have to learn is how to perform operations with complex numbers. Let's refresh your memory real quick on what a complex number is. You see this graph? It is a quadratic. It's not the mother function. The mother function sits right here, right? Okay, so that's the mother function. What is the only solution to the mother function? Meaning, where is it crossing the x-axis? It's crossing at 0. Does everybody recall that? 0 was that anchor point. Okay, now focus your attention on the red quadratic. Where is it crossing the x-axis? X-axis. It's not crossing the x-axis, right? So remember, focus your attention right here. Is it crossing the x-axis? No. So in terms of solutions, you can't just say there's no solution. You would say that it does not have a real solution. Instead, it has an imaginary solution. Here's why. F of x is that fancy y, right? If I wanted to find the solution to that quadratic, I'm looking to see where it's crossing the x-axis. Okay, well, if it's crossing the x-axis, the y value is what? 0. So I'm going to replace this with 0 and show you. If I solve this, I would subtract 1. How do I undo squared? You square root. And now in the past, this is where we stop. We've said, hey, you've got the square root of a negative number. That means not real. We don't go any further. Chapter 3 says, hey, you can go further. Keep going. Isn't that great? You can keep going. Somebody somewhere down the road in math said, I really don't like that I can't take the square root of negative numbers. So enter the I, the imaginary number. This would be imaginary, which means if I was to ask you again, take this quadratic that you see here and tell me what solutions it has, you would tell me that it has 2 imaginary solutions. And the visual is because it's not crossing the x-axis. Now, if I said, hey, here's a quadratic, what are the solutions? Then you would say, oh, it's that number and it's that number. Right? Those would be real. This is an example of when it's imaginary. Okay? All right, go to the next slide. Which brings us to the formal definition for imaginary. You need to have memorized that I is equal to the square root of negative 1. Yep, you need to have that memorized. You should have that. That's from Algebra 1, I think. I think it's taught in Algebra 1. Radicals. No, geometry maybe. You've learned it too. All right, now take that equation. I equals the square root of negative 1. In math with equations, you can do whatever you want to them as long as you do it to both sides. So if I wanted to get rid of that radical, the opposite of square rooting is squaring. So if I square both sides, on the left I would end up with an I squared, and on the right I would end up losing the radical because the square and the radical would cancel. So here's a new one that I probably would say is safe to say you've never seen before. I squared is equal to negative 1. You need to know both. Now, if you forget the new one, just remember I is the square root of negative 1, and if I come in and I square both sides, then then I get I squared equals, and those do what? Cancel, and I get I squared equals -1. So if you forget it, then you should be able to derive it. Now, this is Algebra 2 right here. Let's refresh your memory. Does yours not have this slide? Did I mess up?
I don't think so.
There was one pack.
It goes directly to example 2.
There was one pack. Well, yeah, you should know that. You don't need the rest. You're good. There's one pack. Let's do it right. Sorry. I saw one pack that looked funny the way it lined up, and I wondered. There you go. Oh, yeah. There you go. Copy that down. I'll give you a second. Y'all ran 24, right? Oh, gosh, I have to all see. What's the matter?
What's the red one?
Nothing. That's the one. Yeah. Is that like you're gonna like get your pictures or something? No. No, it's a data room. All right. Look at this right here. This progression of math right here is saying to you, it's showing you an example of where someone down the line was like, hey, I really want to take the square root of a negative number, but you can't. And then they said, well, what if I'm going to apply that right here. What if I just take that radical and I rewrite the negative number as -1 times the positive number? If I do that, and then I create some new math and I'll call it I, then I can have the square root of -1 and the square root of 7. You don't have to write this. I'm just showing you where it came from. I can take the rules of radicals. You can take one big radical and you can split it apart with a multiplication in between, and it's the same thing. If you read this going back up, I haven't changed anything, have I? I've just rewritten the -7 as the product of -1 times +7. What did we just learn that this means? This means I. And then this can come down. So now I have a square root of a positive number, but then I do have an I in there to say, hey, it did come from a negative. So that's the progression that this is showing right here. Now, I'm going to come right here and I'm going to say, so this equals I square root 7. Absolutely. Now, we do need to remember perfect squares. You've got to break them down. We're at that level. So I'm going to come down here and I'm going to make a list. You've got to remember your perfect squares. Remember that I don't want you to have them memorized necessarily. You should be familiar with them. Like if you see one, you should say, oh, that's perfect. But I don't want you to have them memorized because memorization only goes so far. I want you to be able to generate the list. Because if you can generate the list, it'll take you further than memorization. To generate the list, you're just counting to yourself. 1 squared, write it. 2 squared, write it. 3 squared, write it. You see where I'm going with this? Go all the way up to 15 squared at the bottom of your paper. And I'm going to make a note in a different color. Just count 1 squared, 2 squared, 3 squared, etc. That's how you get the list. So making your list, check it twice, then you'll find out who's. No, okay, sorry. All right. I don't know if y'all have learned, but the expensive looking stupid, I like to try to make y'all laugh because I feel like it makes you enjoy the class more. Or if at all. Let's see, 13, 14, 15. Okay. So we're going to use that list. Those are your perfect squares. Let's go to example 1b. It says to take the square root of negative 16. When you see this negative in here, under the radical, your final answer should have an I in it. And we're simplifying it right here. Okay, so I know I'm going to have an I. What I like to do is I like to pull the negative out immediately and say to myself, okay, that means there's an I. And then I like to change it to positive, and now I take the square root of the positive number, which is 4. So this is actually just 4i. Notice the I moves to after the whole number if it comes out as a positive, like as a nice square root. You wouldn't write I4, because that sounds like bingo. You would write that it's 4i. Now this one's a slight trick. What is in the very front? A negative 1. So you just have to say to yourself, okay, so I got a negative 1 there. It is being multiplied. What is this? This is an I of the square root of 13, right? And then negative 1 times I. Okay. Look at the next one. Go ahead and try it. D. Try D. Now go to complex. Try D. Because 64 is in your list of perfect squares, your answer will be a nice, pretty number, no radical. Will it have an I? Yes. Yep. Well.
Yeah, she can do this.
Yeah, it's okay.
Yeah. Maybe. Yeah.
Okay, did you get, so this negative right here is to let you know that you do have a negative 1 multiplying by what comes from this. Because this is perfect, you could go ahead and say this is going to be 8, but it is a negative 64 under there, so it's 8i. And then negative 1 times 8i is negative 8i. E is not as straightforward because 48 is not perfect. Here's where you're going to need your calculator. And I'm running out of room right here, y'all. Maybe not. I'm going to pull E over here because I'm running out of room. So we have the square root of negative 48, right? Okay, first of all, the negative under the radical means I need to pull in I out. So this is going to be I times the square root of 48. We want to break this down in what's called simplest radical form. We don't want any decimals. Decimals you have to round, which means they're not accurate. We want to break it down using our list of perfect squares. Some math teachers, I'm changing colors, there's nothing wrong with this, I don't go this way because it requires more work. Some math teachers will have you break it into a factor tree. You don't have to write this. Alright, so some math teachers will have you break it down into a factor tree, and then you go back and you circle the leads, I guess they call them, or the ends. Look how many steps that took, right? While you're comfortable with the numbers, look how many steps it took. Okay, watch my way. The goal is for that to break into something times something where one of them is a perfect square. I'm going to abbreviate PS. One of them needs to be a perfect square. Because if I want that to be able to go any further, I need to be able to take the square root of something pretty. So find where that number falls on your list. Find where 48 falls right there. Which means I don't need to check any of these other numbers because they're too big. And then start dividing by the number that it's just under, and then go to the left. You don't want to start over here at 1 because there will be some numbers that have multiple perfect square factors, and you always want the largest one. So in order to avoid that problem, if you'll find where it falls and then start dividing this way, you'll always hit the larger one every time. There's no way 36 goes into 48 nicely, right? You can go to your calculator, you can divide 48, divide 36. When it's a decimal, that means move to the next one. 48 divided 25, decimal. 48 divided by 16. Winner, winner, chicken dinner, right? So I'm going to put the 16 here because it went. And how many times did it go? 3. I'm going to bring the I down so I don't forget it. What is the square root of 16? 4. So this right here is actually 4i. This comes down. That was 2 steps as opposed to that big factor tree that was like 6 steps. Now, I'm going to go red means wrong here. Don't write this. If you forget to find where it falls and start with the big number, if you forget that, and you just start counting over here, you're going to run into this problem. 4 times 12 is 48, right? Isn't it? And 4 is perfect, right? And you think, oh, it's 2i square root 12. Is that the same as that? Not, now, decimal-wise it is, but as far as what it looks like, they're totally different. What other perfect square goes into 12? There's the problem. You don't want this. You don't want to have to do it again. So if you'll find where it falls and start with the big number, that will never happen. Ever. Okay? All right. Questions on that slide? Okay, go to the next slide. What if we have a number that is part real and part imaginary? Well, that would be a really complex situation, right? No. Okay. Complex numbers. Think complicated because it has real and imaginary parts. What is a complex number? It is a number that has a real part to it and an imaginary part to it. There is a certain format that it has to be written in, and it is right here. the format is A plus BI, meaning the real number gets listed first, the imaginary part gets listed last. Okay? If you have an imaginary number, like for example 17i, right? There's no real part to it, then it is called pure imaginary. That's not really going to come up as far as us using that vocab word. You just need to be able to recognize that if it's the square root of a negative, it's imaginary. If it has an I, it's imaginary and it came from the square root of a negative. If it's a real number, a real part, it will not have an I. And it will not be the square root of a negative number. I mean, it should be obvious. It's a number you're used to. Okay? Go to the next slide. Now we're going to do basic computations and arithmetic with complex numbers. Recall, for instance, x plus 2 minus, I'm going to go ahead and go to the minus one because that's the one that trips people. Let's say 2x minus 3. Y'all are already familiar with that, right? You would distribute the negative and then you would combine like terms. Same exact concept. Instead of an x, we have an I, which is saying it came from an imaginary. So like right here, focus on what's in between. Don't let the parentheses make you think it's multiplication. The multiplication of parentheses is only when they're touching. You know, like a binomial times a binomial, that's multiplication. The parentheses here are just letting you know, hey, here's a complex number, here's a complex number, add them together. Okay, so it's going to be real to real, real to real, and imaginary to imaginary. So 8 plus 3 is 11. 6i plus positive 2i is 8i. More of those, please. Right? And you go to B. Just like with polynomials, you have to do what before you can combine here? You've got to distribute this negative. Right here, there's a negative 1, and it is multiplying to everything after it. Bring this crap down. Unchanged. That's a positive 6, becomes a negative 6. That's a negative 3i, becomes a positive 3i. And then now check your real numbers and your imaginary numbers. So this is real, this is imaginary, this is real, and this is imaginary. So 4 minus 6, and positive 5i plus 3i, 8i. That one. Quiz. I think it's a quiz. Edge elastic. Go ahead and go to edge elastic. I can unlock her. What? No, imaginary goes at the end. Look right here. The imaginary part always comes at the end. It's the dilation stuff. It's the dilation. Those are dilations over there. Just multiply them. Just multiply them. All right, let's go to the next slide. Yes, Connor. Classroom like a bigger one? I know, that was when Riles was much smaller. He's like up to here now. All right, go to the next one. I don't think we need to practice any more addition and subtraction. What do you think? I think we're good. Okay, let's go to multiplication. Here's where you've got to remember, if I'm taking an imaginary number and I'm multiplying it with another imaginary number, you still need to recall that it came from imaginary, right? Okay, so if you look right here, there are two different ways that some people see this. One of them's correct and one of them's wrong. I'm going to go ahead and put a big green check right here, because this one's right. And then I'm going to put a big red X right here. This one's wrong. If you want to just scratch that one out, if you think it's going to confuse you, you can. You can do one nice little line through it to say, hey, that's wrong. And now I'm going to show you why for each. Like why one's right, one's wrong. Okay, so looking right here, this is the square root of -2. This is the square root of -5. The wrong way would put you being done immediately, so that would be your clue that you've done it wrong. You should know there's going to be more work involved. We're at a college level class, right? So there's no way, oh, I just wanted you to do -2 times 5, and that's 10, and that's the answer. There's no way that's the right answer. Because if you do it that way, you've completely forgotten that they were imaginary. See what I mean? So this is wrong, and your clue is it was way too short. There's no way that that was right. Come up here. Square root of -2. That is an I, correct? All right, so you'll notice right here, I really go from here to this line. I pulled an I out, and I left it as the square root of 2. This one is the square root of -5. That's an I. So I'll pull the I out. I'm showing you right here where they pulled it out. Pull the I out, and then you can write the square root of 5. Now, because that's a 2 and that's a 5, you actually can multiply those, correct? And then you have I times I, which is what? I squared. This is the new part that we've not had yet. What is I squared? -1, remember? So -1 times the square root of 10 is negative square root 10. See the difference? So it's a totally different approach. One is correct, one is wrong. The correct one will involve you writing I's. So that's another way to know not to go like this way. There was not a single I in there, correct? If there's a negative under a radical, you better have an I somewhere along the way. Now, doesn't mean you'll have an I in your final answer, because in this case we had 2 of them, which multiplied together nicely and gave me a negative number. But at some point in my math, did I not write, I wrote an I down, right? That's how I know I'm going the right way. Okay? Let's practice. Come down here. We have the square root of -16 times the square root of -25. Are these both perfect? So let's fix them. This would be 4I times 5I, and that's 20I squared, which means this right here, when we get to, let's see, is it the next one? No, I think it's 3.2 homework. Oh no, it is. It's the very last slide. Yeah. When you have a term with an I squared, I want you to start training yourself to circle it. This is gonna come in handy on the last slide. Train yourself to circle it and tell yourself, I see positive 20I squared, that's a -1. So this is actually -20, and then you drop the I squared because you just accounted for it. So this is the final answer. Now, where did it come from? We'll come over here and show you where it came from. It came from 20 times -1. That's where it came from. Now, just like with binomials with x, we have a binomial times a binomial here. It's first, outer, inner, last. It's the distributive property. So if that was something you struggled with in chapter R, here's a chance for you to master it because it's coming up again. Remember that the first, outer, inner, last, the FOIL thing, it only works when it's 2 terms times 2 terms. So we're going to do first, outer, inner, last. Multiply the first term times everything in here. So that would be 1 times 1, 1 times 3i. Right? Then multiply the second term times everything in the parentheses after it. So that would be 2i, and 2i times 3i is 6i squared. Just write it. Yes, it is an I squared, just write it. That's what the next line's for. Now, look for any like terms. So right here in the middle, I bring the 1 down. This becomes 5i, and this is where I said, train yourself to circle the entire term, including its sign. And tell yourself, that's a positive 6i squared. I squared is -1, so that's actually -6. So then I'm going to come right here and write -6. Now, 1 minus 6 is -5. Bring down the I part, and that's the answer. Remember, the imaginary part goes at the end. C is, do you remember that when you have a binomial squared, it means the binomial is multiplying by itself. So I want you to come underneath it, and it means take this graph, write it twice. That's what it means. So take 3 minus 7i and write it twice. Now it's an exact repeat of B. First, take that first term, multiply it to everything in here. What would you get? 9 minus 21i. Take the second term, including its sign, multiply it times everything in here. -21i plus 49i squared. Guys, even to this day, with a master's in math, I still write the I squared because on the next line, I know I'm going to take care of it. Don't try to do it in your head because then you're going to end up, you might cut too many corners and you might start blurring the lines and get it wrong. All right, so now what can I do? This and this. Don't get too excited and cancel them out. They have the same sign, which means they actually add together. So that's -42i. I'm going to bring this down. Training myself to circle any I squared terms with their signs. So that would actually be -49. Once you account for it changing sign, you drop the I squared. So bring this down, -49. You have a graphing calculator? Take your graphing calculator. Hit mode. Edna, mode. Sorry. Hit mode. You see where real is highlighted? You see that? You see right next to it? You see A plus BI? You can tell the calculator to go to imaginary mode. You have to enter it so it'll stay on it. Then you get out of this, so second quit. Now I want you to type the square root of negative 16 times the square root of negative 25. You will notice your calculator no longer gives you an error. Now it actually does it. Now let's enter 1 plus 2i. 1 plus 2. You've got to look at your calculator to find the I button. I don't remember where it is. Thank you. Mine's blurry up here. Hit second and then the decimal. Then close parentheses. What did we have? Parentheses. 1 plus 3. Close parentheses. Whoa, there it is. And 3 minus 7, I caret 2. That's what we got. What if it's a radical that you're not comfortable breaking down and you're like, I don't know if I did this right, like the square root of negative 21. This is where we do have a problem. Notice that I entered the square root of negative 21. Y'all should know 21 has no perfect factors, right? It's going to spit it out as a decimal. Now, it does have an I at the very end. So this is where the calculator is great for complex numbers, but it's not perfect when breaking down radicals. It's only great when it's a nice breakdown. If it's one that does not break down, it's going to produce a decimal, which is not going to be one of your answer choices that's accepted by my math lab. They're going to want it in radical form, which means they're going to want the square root of 21, and then of course it would have an I in the front. So let's make a note on this slide right here. Let's make a note. Be careful. ... Like for in the calculator, if you set the square root of negative 21, it's going to give you a decimal, but we want it to produce it as I square root 21. So you need to not rely on the calculator for every single one of them. Maybe use it as a checkpoint. All right, we have 3 slides left. Go to the next slide. What if I ask you to evaluate I to a higher power? Well, let's look at how this pattern unfolds. What is I? I is the square root of negative 1. Okay, if I square both sides, I end up with I squared equals negative 1, right? Okay, what if I wanted to evaluate I cubed? Look at the progression. Rules of exponents say I can rewrite I cubed as I squared times I to the first power. That's the rule of exponents. And what is I squared? -1. And then the I just carries over. So what's -1 times I? -I. Stay with me. What if I wanted to evaluate I to the 4th? Well, I could rewrite that. Coming back to the squares, I could say that's just I squared squared, right? What is, you'll notice, I'm going to highlight it so it stands out. You will notice I squared is your anchor to rewrite this nonsense. What is I squared squared? I can rewrite the I squared as -1. What's -1 times -1? 1. Come back over here. What about to the 5th power? Well, isn't that just to the 4th power times 1? What is the 4th power? Well, I just showed you. It's I squared squared. What is I squared? -1, which is +1 times I is I. What do you notice about it starts back over? There's a pattern. It repeats every four increments that you raise it up. Okay? So let's make some notes. From here to here is a pattern. It's a pattern. What do you need to remember? You need to remember this one. Remember the very first one. And then be able to produce the 4 increments. You really should have the second one remembered as well. I squared is -1. And then the last 2 come from rewriting it using I squared and replacing it with -1. Okay? So what you need to have memorized is that I is the square root of -1. I squared is -1. I cubed is -I. And I to the 4th is 1. Then it repeats. Okay? I would not sit here and try to necessarily memorize that because you could easily mess it up. I would remember how to generate it. I would practice generating it. And it comes from knowing the very first one. Then you square both sides. Then you pull an I squared out, replace it with -1. Then you pull an I squared out. That would leave this at 2 because it had to go to 4. Replace it with -1, and then you evaluate it. Okay? Get comfortable with that because this should be a gimme. Like, you should never get these wrong because it's a pattern of just the same 4 things. Now let me show you how to actually use it. I to the 37th power. Yes, I know you can type it in your calculator. Let's look at it by hand. And I think I need. All right, I to the 37th power. You're going to take the exponent, and divide it by 4. I'm abbreviating. Take the exponent, divide it by 4, and check the remainder. You're going to take the exponent, divide by 4, and you're checking the remainder. You don't care what you get when you divide by the 4. What you care is what's the remainder, meaning what's the decimal. All right, so here we go. 37 divided by 4. I'll just come over here. So 37 divided by 4 is 9.25. Right? Okay, if it had gone nicely, let's say it was 36 divided by 4. That's just 9, right? That means there's no remainder. Remainder would be 0. So you would go back and calibrate it and say, what's I to the 0 power? That's 1. Anything to the 0 power is 1. This is 0.25. I want you to think quarters. Why am I saying quarters? Because there's only a pattern of 4. How many quarters is this? I want you to take this is your thought process. Oh, I divided the exponent by 4. I got this. Oh, I see 1/4. Oh, I need to think remainder 1. So this nonsense here is going to be the same thing as I to the first power, which is why this little anchor chart is helpful. I to the first power is just I. You don't have to leave it as the square root of 1. So I'm going to come right here and put this is I to the first power, which is just I. Now, I don't expect you to know what I just did by seeing just one example. Give me 3 more examples, and then I think you'll understand it. Let's go to B. 58. So I to the 58th power. 58 divided by 4 is 14.5. Draw an arrow. That means a remainder of how many
2.
how many quarters? 2. So this here is going to be the same thing as I squared. What is I squared? -1. That's the answer. Let's go to C. I to the 75th power. Okay, 75 divided by 4. 18.75. Direct your attention to the decimal. How many quarters is that? So that's a remainder of 3. So this is the same answer as I cubed. Now this is where you need that chart, or you need to generate it. Tell yourself, okay, I cubed. That is I squared times I, and I squared is -1 times I is -I. Like when we take this test, the first thing I would do when you start the test is I would generate this list so when these questions come up, because there's probably only going to be like 1 or 2. That way you have it. Okay? Let's do another one. 80. 80 divided by 4 is 20. That's it. Right? So I'm going to draw an arrow to nothing, like 0.0. So the remainder is 0. Which means it's I to the 0 power. Anything to the 0 power is the number 1. The 37th, so we did 37 divided by 4, we got a remainder of 1. So it's the same as I to the 1. Which is, well, they want you to leave it as an I. The square root of -1 is there to help you generate the next part. But yeah, they want you to leave it as an I. Alright, go to the last 2 slides. Y'all with me on this? Okay. Last 2 slides. The word conjugate. Complex conjugate. It's when you take a complex number and you change the sign of the imaginary part. That's all it is. So look right here. -3 plus 7i and -3 minus 7i are complex conjugates because you changed the sign of the imaginary part. Okay? Now, 14 minus 5i and 14 plus 5i are complex conjugates because the imaginary part has a different sign. There's a reason for this. You know how in math we say you can't divide fractions? You do what instead? You keep, change, flip, right? You multiply by the reciprocal of whatever the bottom part was. In math, you can't divide complex numbers. You don't actually divide. You multiply by the conjugate of the denominator. So it's almost like with fractions, you multiply by the reciprocal. Okay, with complex numbers, you multiply by the conjugate. There's no reciprocal of a complex number because it doesn't exist. But you multiply by its conjugate. Okay, so it's the same concept. Those two were just refreshers. Come right here to this one. If I tell you divide this by this, it means to put it like this in a fraction. Correct? By means, like if I say divide this by this, it means that better go on bottom. Correct? Here's the new part. You never actually divide it all. You're going to multiply, make a note, multiply by conjugate of denominator. I know the bell's going to ring. I'm going to finish this problem because it's 3 lines. You're going to multiply by the...
Tracy, Gracie, will go into the office, please.
Yes, ma'am.
Thank you.
You're going to multiply by the conjugate of the denominator. So, focus on the denominator. Conjugate, we're going to change the sign to plus. Now, changing colors. Now, if I'm multiplying by that in the bottom, aren't I changing the value of the whole fraction? Remember with fractions, like when you multiply by something, what do we need to put it over so I'm not changing its value? The same thing. So this is a big old fat fancy 1 that I'm multiplying by. And what it's going to do is it's going to get rid of the imaginary part in the bottom of the fraction because now you have what's called a difference of squares in the bottom. Okay? So this goes back to a binomial times binomial and a binomial times binomial. So here we go. 2 times that crap would be 2 plus 12i. Negative 5 times that crap would be negative 5 minus 30i. Squared, right? 5i. Negative 5i times 6i would be negative 30i squared. Repeat on bottom. 1 times 1. 1 times 6i.
The middle, the top, negative 5.
Thank you. Negative 6i times 1. And negative 6i times 6i. Now it's just a matter of cleaning it up. You have like terms right here. These are like terms every time. And then you have this one over here on the end that you can do what with it? You're going to change it. So it would come down to, here we go, 2. Let's see, 12 minus 5 is 7i. I see negative 30i squared. It would become 30, positive 30, right? On the bottom, what happens here? Every time. Every single time that will happen on the bottom. Every time. All day, every day. And I end up with 1. That becomes plus 36. You will notice there are no longer i's in the bottom, which was by design. So I end up with 32 plus 7i over 37. I'm going to make a note. You can write this tomorrow morning if you want. You'll always have a difference of squares on bottom. And that was because because you use the bottom to create the conjugate to multiply. So it's by design, okay? Hold on, let me pause that.